Hello and welcome to my channel. Today I'm going to repair a few video cards, one of which is this Gigabyte 1080 Ti Gaming X. Seems to have some kind of a fan problem and we're going to be looking at it later in the video. Another one is a Gigabyte 1070 Ti that I already fixed by replacing one of the memory chips, but the fans do not spin. And then everyone's favorite for some reason, the RX 580 that also has a memory problem. And last but not least is this EVGA 1070 FTW, which already works, but I would like to mention a thing or two about the memory testing, so let's begin. I'll start with an easy one, with a non-working fan to see what's causing the problem. To make my diagnostic easier, I will simply plug this fan into a working card and see if it works. And to my surprise, it does. Okay, so if fan works on another card but not on this one, what could possibly be a problem? Well, in order for this fan to work, board has to send voltage pulses to the fan power line, which on this card comes from this pin right here. You can see on the oscilloscope that impulses do present, but what's funny is that they're in reverse order, at least compared to other cards. Seems to me that all I have to do is to flip the wires on all connectors to match to what's on the board. And honestly, I don't know what could have happened. Why this card comes with cooler that has every wiring connector reversed? I don't know, and I don't care. So the fans and the LEDs are working now, and the test shows that the card is performing as expected, and that's really all we want to see. Next on the list is this overrated, overpriced, not the most terrible card in the world from MSI, the RX 580 with 8GB of memory that I suspect has a bad memory chip, so let's run some tests and see if that's true. In case you're not familiar with AMD cards, the software you need is known as a T-server. In order for the T-server to test the card, I have to set my motherboard to use built-in GPU as a primary source for display. Otherwise, the RX 580 outputs no pictures, so I won't be able to see anything, and I will not be able to run the test that I would be able to run with an NVIDIA running Matt's test, for example. So the image you see right now actually comes from the built-in GPU. The RX 580 is installed as a secondary device. Okay, so I will pick the test that shows my card and wait for the login prompt. Root is the login. Then I type ls to see the list of cards I can test. RX 580 is on the list, but there's a catch. I don't want to run the test for RX 580. I want to run the test for 580. Don't ask me why, I didn't make this. Each model listed here is actually a folder from which test is performed. And for that reason, we need to navigate ourselves into that folder before we can run the test. To do that, we type cd space /mods/580. Now I will erase the old log file with rmmempha.log. You will get an error if this file already erased, and you have to do this every time you want to run the test. And now we type /tserver space dash board test equals mempha and wait for the test to complete. Once test is complete, I need to see the log file by typing pico mempha.log. The results are up above, so I need to hold shift and press up to look up higher, and there it is. And it says we have a bad memory on channel C1. Now let's count the memory chips to identify the correct one. With NVIDIA cards, the chip countdown goes as follows: A1, A0, B1, B0, C1, C0, D1, D0. With AMD, it's the same except the count starts from 0. A0, A1, B0, B1, C0, C1, D0, D1. So in my case we have a C1, and that's the chip we're going to be replacing. I'll start with preheating the board to make the process go smoother, and once everything's hot, I'll start applying the heat with the air gun at the temperatures around 350. Once the chip starts to move, I'll lift it up, clean the place up with some leaded solder and wick, and put a new chip. After cleanup and assembly, we are ready to see if that worked. When I'm testing my cards, I like to load the memory to the max and the GPU, and I'm using programs such as OCCT and Firmark. In my book, this is the most aggressive test I can perform without any performance tweaks. Goodbye with the RX 580 and hello Gigabyte 1080 Ti. This card came described as broken, so let's see what's broken. Using my cheap camcorder zoom to look closer, I see that we have some knocked off components here in the front and a few on the back. Now let's see if this card has any chance of survival by measuring the resistance in the key points. Next test I like to do is to see if any of the data lines are compromised. And it looks like we have two lines that are not working. Those are the lines where we have two missing capacitors on the back. After replacing broken off fuse and few knocked off capacitors both front and the back, I tested the data line again, and this time it seems okay. Next step is to see what kind of amperage card draws while it's in the idle state. I'll plug it into my test rig, and it shows me that it uses roughly 1.5 amps, which is a good sign. And now I will confirm that we have all the voltages present by checking those same key areas as before. With everything checked, it was time to plug it in and see if we have a picture. And picture we do have. That's good. Now it's time to clean all the bugs and the dust from the card before we can run any more tests. And as you can already see, the card does work, but we have a problem. The problem does not look like a memory chip problem. In fact, I ran the memory test already and it passed. This looks more like a power related problem, so let's take this thing apart and have a poke around with an oscilloscope. After checking all the power stages and finding nothing suspicious, I turned to a microscope. Another suspect was the GPU itself. If you look closer, you can kind of see that one end of it is squished more than the other. That could possibly be a problem, or it may not be, I don't know. The last place to look for a problem was on forum online, when one of the guys suggested that I should try HDMI port instead of the DVI. And to my surprise, the HDMI port was not showing any of the glitches that I've seen before through the DVI port. There are several possible causes for this: rusted connection, broken traces, damaged or knocked off components, and poor connection to the chip itself. Since I'm lazy and I want things done fast, I'll just check for any damaged traces, paying close attention around the holes, and I'll check if all the pins of the DVI connectors making their way to the GPU chip. And we check those in the same fashion as we check the data lines in the diode mode. All of the signals should be the same. After poking around, I found that some of the pins have intermittent contact loss, leading me to believe that there's a poor or detached soldering joints onto the GPU. This may very well be our problem, so let's put this board on the preheat station and reflow the GPU, hopefully restoring the contact points under the chip. I could reball the chip, but I'm too lazy and this seems like it would do the job anyway, so why bother? And as usual, before you plug anything in, you want to double check for all the key areas for resistance, and then recheck the DVI pins that we've checked earlier. And it looks like everything's okay, and we can proceed with confirming the fix. And as expected, the repair was a success. A few benchmark stress tests later, this card is given a second life. And with that said, I thank you for watching. Please consider subscribing to my channel and comment below to help me grow, and have a blessed day and goodbye. Oh, and I almost forgot to say that when you test memory with mats, if you get any errors, try a different version of mats, as there are many, and they are not all equal, especially depending on where you got it from. And that's it for now. Like and comment, and thanks.